GitHub Hot today, featuring limit research on theoretical limitations of embedding-based retrieval. ACP Claude Code. The ACP implementation for Claude Code and CM5 Revin, reverse-engineered Raspberry Pi Compute Module 5. Welcome to GitHub Hot today. Let's dive into these exciting projects. Ever wondered why your AI search sometimes misses the obvious? Google DeepMind's LIMIT project reveals a shocking truth about embedding-based retrieval that might make you question everything. The team discovered that for any given embedding dimension, there exists a combination of documents that simply cannot be returned by any query. It's like having a library where some books are invisible to the librarian. They created the LIMIT dataset to stress test embedding models based on solid theoretical principles, and the results are eye-opening. Even state-of-the-art models struggle with what should be simple tasks, highlighting a fundamental limitation in our current single-vector embedding paradigm. The dataset comes in two flavors, a full version with 50K documents and a small sample with just 46 relevant documents, making it accessible for different research needs. DeepMind also provides code for generating LIMIT-style datasets and running free embedding experiments, so researchers can reproduce and build upon their findings. Published on RxEv, this research from Orion Weller and team shows that even when optimizing parameters directly on test sets, these theoretical limitations persist. This implications are profound. We may need entirely new approaches to overcome these fundamental barriers in AI retrieval systems. As the field evolves, LIMIT serves as both a pattern, wake-up call, and a benchmark for the next generation of retrieval technologies. This isn't just another research paper, it's a reality check for the entire embedding community. What if you could supercharge your Claude Code experience with seamless editor integration? Meet the ACP Claude Code Bridge, your ultimate connector between Claude's powerful AI and AI, the Z editor. This brilliant bridge implementation enables Claude Code to work with the agent-client protocol, opening up a world of possibilities for developers who want AI assistance right in their coding environment. The architecture is rock-solid, providing session persistence that maintains conversation context across multiple messages, so Claude remembers what you are working on even after complex interaction. You get streaming responses in real time, full tool call support for Claude's advanced capabilities, and seamless message format conversion between ACP and Claude SDK formats. It's like having a universal translator for AI coding assistance. Setting it up in Z is a breeze with flexible configuration options, from basic setup to advanced permission modes that let you control how Claude interacts with your files. The bridge supports 3 permission modes: default for safety, accept edits for workflow efficiency, and bypass permissions for power users who live on the edge. Development is straightforward with PMPM support, hot reload for rapid iteration, and comprehensive debugging capabilities when things get tricky. Authentication is handled seamlessly through Claude Code's built-in system, so you don't have to juggle multiple credentials or worry about complex setup procedures. The technical implementation is impressive, using a 2-step session management approach that maps ACP sessions to Claude's native session management for optimal performance. With features like rich content display, dynamic permission switching, and robust error handling, this bridge transforms how developers interact with AI coding assistants. Whether you are a solo developer or part of a large team, the ACP Claude Code Bridge brings the power of Claude's AI directly into your favorite editor, making coding faster, smarter, and more enjoyable than ever before. Ever wondered what's really inside that Raspberry Pi Compute Module 5? One brave reverse engineer decided to find out by literally taking it apart layer by layer. This incredible project showcases the complete reverse engineering of the Raspberry Pi Compute Module 5, revealing secrets that Raspberry Pi Foundation never intended for us. The engineer used some seriously impressive techniques, removing all components, measuring them with an LCR meter and VNA, then sanding down the board one layer at a time and imaging each at 9,600 dpi with a flatbed scanner. Talk about dedication to hardware hacking. The discoveries are fascinating. The board has a complex 10-layer structure in a 2+6+2 configuration with 4 layers of micro vias, buried mechanical vias, and standard through-board vias. Those resistors in the upper right corner aren't just 0-ohm jumpers. They're specific resistor values forming a voltage divider so the RP1 can measure memory and eMMC configuration through ADC inputs. The PMIC features a hot swap function to limit inrush current to the massive 350 UF capacitance on the 5V rail. And you can even monitor supply current by measuring voltage across the known MOSFET. The project provides a complete test point list with precise coordinates, turning this reverse engineering effort into an invaluable resource for advanced hardware hacking and educational purposes. With the PMIC pinout now known, adventurous hackers could explore the I2C register map or even salvage a blown CM5 by removing everything except the PMIC and reprogramming it for other projects. The Wi-Fi and Bluetooth functions can be disabled through GPIO, and there are clever design choices like the SD pens being unconnected on eMMC versions to prevent conflicts. End of section 10. This isn't just about copying a design. It's about understanding the engineering choices, the signal integrity considerations, and the clever solutions that make modern computing hardware work. For the hardware hacking community, this reverse engineering project is like getting the source code to proprietary hardware. It opens up possibilities for custom modifications, repairs, and entirely new uses for the Compute Module 5. Whether you are a professional hardware engineer, a curious student, or just someone who loves taking things apart to see how they work, this project demonstrates the incredible depth of knowledge that can be uncovered through patient, methodical reverse engineering. That's all for today's GitHub Hot projects. Thank you for watching. Please subscribe to our channel GitHub Hot today. See you tomorrow.